Until I'm getting it, there will be the questions based on Gauss law or H C Verma problems. And normally we will try to do 10 questions today. हमें first question में दिया है that the electric field is given in a region as 3 E naught by 5 I cap plus 4 E naught by 5 J cap. Find the flux through the rectangular surface of area 0.2 meter per second square in YZ plane. So the key concept which is used in this is the flux through a given area is the dot product of electric field and area vector. We have to treat area as a vector quantity. And we always know that direction of area vector is perpendicular to the plane which is given. In this case, we are given YZ plane. And its area is given as 0.2 meters square. Now, when it's YZ plane, the direction perpendicular to YZ plane will be x-axis. So 0.2 I cap. And electric field is given as 3 by 5 E naught I cap plus 4 by 5 E naught J cap. Mathematically, flux is its dot product of electric field and area vector. So 3 by 5 E naught I cap plus 4 by 5 E naught J cap and 0.2 I cap. I dot J is 0. So flux comes out to be because I dot I is 1 and I dot J is 0. E naught हमें given है question में. It's 2 into 10 raised to power 3 into 0.2. So 6 into 0.2, 1.2, 1.2 by 5, 124. Or 240. And because flux calculate here, the unit will be Newton meter square per coulomb. So we have basically used the concept that flux is dot product of electric field and area vector. And area vector की direction is always perpendicular to the plane. So plane is given as YZ. So area vector will be along x-axis. Second question is, a charge Q is distributed uniformly over a rod of length L. Consider hypothetical cube of edge length L with the center of cube at one end of the rod. Minimum possible flux through the entire surface of cube. हमें given है cube of edge length L. Hypothetical cube of edge length L. So let's make a cube of edge length L. A rod is placed at its center. One end of the rod is at the center. Means you have a rod like this. Its length inside the rod, minimum length which can be present inside the rod is L by 2. Means half of the total rod is inside the tube. You have to tell the flux. A total charge on Q1, total charge is Q. Charge inside cube is half of it. मतलब अगर पूरी rod पे Q है तो half rod पे it's Q by 2. The key concept is that Gauss law says the flux depends only on the charge inside the Gaussian surface or inside the closed surface. In this case, charge enclosed is Q by 2. Gauss law says that flux is Q enclosed by epsilon naught. Q enclosed is Q by 2. So flux inside the Gaussian surface is Q by 2 epsilon naught. So आपको जब भी इस तरह का क्वेश्चन आएगा you just have to find that what is the total charge enclosed inside the Gaussian surface. Total charge enclosed inside the Gaussian surface अगर Q by 2 है तो flux will be Q by 2 epsilon naught. And if there is no charge enclosed inside the Gaussian surface, then flux through the Gaussian surface is also zero. So आपको सिर्फ charge calculate करना होता है कि what is the charge inside it. एक बार charge calculate कर लिया तो you will find the answer. नेक्स्ट क्वेश्चन अगर हम देखें थर्ड क्वेश्चन इज so that there can be no net charge in which electric field is uniform at all points कि अगर electric field uniform है you have to show that there cannot be a charge inside it. Now if you assume any closed surface हम किसी भी shape का closed surface ले लें and it's placed in uniform electric field so you have to go back to the basic concept कि flux through the closed surface is the number of lines of force entering or leaving a closed surface. अगर यूनिफॉर्म इलेक्ट्रिक फील्ड में मैंने कोई भी आर्बिट्रेरी शेप बनाई even if I draw an arbitrary shape and there is uniform electric field means field lines should be straight, parallel and equidistant. So you have a closed surface placed in uniform electric field. You observe that when the electric field is uniform, The number of field lines which enters from one side will always be equal to number of field lines leaving from the other side. और अगर number of field lines entering or leaving same है, this implies that flux through the closed surface is zero. Gauss law says flux is Q enclosed by epsilon naught. तो अगर flux zero है, that means charge enclosed inside the Gaussian surface will always be zero. So it's a kind of theoretical question where we use the concept that fluxes, the number of field lines entering or leaving a closed surface. So it's the net number of field lines. And it's Q enclosed by this is Gauss law. So in uniform field, net number of field lines are zero. Implies flux is zero. And this also implies that charge enclosed is zero. सो हमें नंबर ऑफ फील्ड लाइन से ही पता चल जाता है कि अगर जितनी फील्ड लाइंस एंटर है बिकॉज इसके अंदर अगर पॉजिटिव चार्ज होता है नेट चार्ज पॉजिटिव तो इसे फील्ड लाइंस लीविंग द क्लोज सरफेस विल बी मोर देन फील्ड लाइंस एंटरिंग इट नेगेटिव चार्ज होता है तो फील्ड लाइंस एंटरिंग विल बी मोर देन फील्ड लाइंस लीविंग so if the number of field lines entering and leaving are equal this implies that charge inside the Gaussian surface is zero. Next is electric field is given in a region as E is equals to E dot X upon L I cap. Electric field is given as pointing in X direction where E naught is 5 into 10 raised to power 3. So basically 5000 X by L. And L is 2 centimeter. We have to find the charge contained inside a cubical volume. अब हमें already इलेक्ट्रिक फील्ड दी है जो वेरी कर रहा है यूनिफॉर्म नहीं है and when closed surfaces there an electric field is non-uniform that means field lines entering and leaving are not equal तो अगर हम नेट फ्लक्स कैलकुलेट कर लें जैसे फ्लक्स इज Q enclosed this net flux into epsilon naught हमें दिया है that cube is placed between and cube is of dimensions x a दिया है एक साइड उसकी so अगर मैं cube ड्रॉ करूं so you have cube of this guy से इसका x एक्सिस हो जाएगा ये y एक्सिस y z एक्सिस electric field is given along x axis अब फ्लक्स होता है सिर्फ तब अगर इलेक्ट्रिक फील्ड passes through a given surface अगर हम इन सर्फेसेस में 6 सर्फेसेस है क्यूब के, इफ यू प्लॉट द डायरेक्शन ऑफ एरिया वेक्टर्स, तो हमें बेसिकली पता चल रहा है कि सिर्फ दो एरियाज ही हैं which are along x axis. इसका एरिया वेक्टर प्लॉट करोगे तो इधर, similarly for top and bottom surface it's along z in minus z axis. सिर्फ इन दो सर्फेसेस के लिए फ्लक्स कैलकुलेट करना पड़ेगा, because top surface के लिए electric field and area vector they are perpendicular, for bottom surface they are perpendicular, for front and back they are perpendicular. इसके लिए x की वैल्यू दी है a, और इस सरफेस के लिए x की वैल्यू दी है 0. दैट मींस इधर से कोई इलेक्ट्रिक फील्ड नहीं है, because x 0 है तो इलेक्ट्रिक फील्ड विल बी 0. So you just have to calculate flux through one surface only. इसके लिए x की वैल्यू a है and a is given as 1 centimeter and L is 2 centimeter. So 5000. So basically electric field is given as 2500 Newton per coulomb. तो flux through the surfaces, because एक surface के लिए calculate करना है, and area is 2 का square. So it comes out to be 1 Newton meter square per coulomb. So you just have to find the values, because हमें E भी दिया L भी दिया, and then you can find the charge enclosed. So यहाँ से आप charge enclosed को निकाल सकते हो कि charge enclosed कितना हो जाएगा. Just see the calculation में कोई गड़बड़ ना हो. Because x is equals to a, y is equals to a, x is equals to 0. Area vector A is 1. So area vector is 1. Area vector is not 2. So यहाँ पर मैंने mistake की. Side of cube is 8. So this is 2500. So 0.25. Not 1. So because area जो हमें दिया था side of cube दी थी, it's 1. It's not 2. So मैंने 2 लेके solve कर दिया था, उसको 1 देना है आपने. So 1 लेके solve करोगे तो you will get the answer. Next is a charge Q is placed in the center of Q. Find the flux through 6 surfaces of the cube. 6 surfaces of the cube. ये आसान है, because it's a simple Gauss law. Because charge enclosed Q है, the flux is Q by epsilon. कि हमारे को ऐसे दिया है. You have a charge Q placed over here. So flux through all six spaces. Flux through all six spaces is Q by epsilon E. Then you are given a charge Q is placed at a center C above the center of horizontal square of HA as shown in figure. Find the flux through the square surface. अब ये ओपन है इट्स पहले अगर आपको गॉस लॉ अप्लाई करना है यू हैव टू मेक इट अ क्लोज सरफेस तो आप ये मान लो कि हमें सिर्फ क्यूब की बेस दी है हमें सिर्फ बेस दिया और हमें क्यूब बताना है तो हम इसको इस फॉर्म में ड्रॉ कर सकते हैं कि हमें ऐसे गिवन है इसमें से फ्लक्स बताना है तो फर्स्ट मेक अ कंप्लीट क्यूब और यहाँ एक चार्ज पड़ा है क्यूब तो फ्लक्स थ्रू कंप्लीट क्यूब इज फ्लक्स थ्रू कंप्लीट क्यूब मतलब सिक्स फेसेस Let's do by epsilon naught. The flux through one phase is it's 1/6 of total flux. अगर 6 सरफेस होते हैं so it will be q by 6 epsilon naught. So total flux पहले जब भी आपको ओपन सरफेस दिया होगा ना you have to make a complete surface. Imagine करो कि इसको कैसे हम complete कर सकते हैं फिर टोटल क्लोज सरफेस में से फ्लक्स पता है you can find the flux through one side कि एक साइड से फ्लक्स कितना हो जाएगा. Next is find electric field flux of electric field through a spherical surface of radius r due to charge 10 raised to the minus 7 at a center and another equal charge 2r away from the center. So एक charge center पे and another charge is at a distance of 2r away from the center. एक charge given है. We have a closed surface. एक charge तो यहाँ पर है. और एक charge इधर पड़ा है बाहर at a distance of 2r. We know that electric flux through closed surface depends only on the charge enclosed. बाहर वाले charge के कारण flux पे effect नहीं पड़ेगा. It can affect electric field at any point on the surface, but it will not affect the net charge. Because इसकी जो field lines होंगी, जो second charge के अगर मैं field lines draw करूं, तो एक साइड से एंटर करेंगे दूसरी साइड से लीव कर जाएंगे क्लोज सरफेस के बिकॉज वो बाहर पड़ा है तो फ्लक्स डिपेंड्स ओनली ऑन द चार्ज इनक्लोज्ड इज 10 टू द पावर -7 तो अगर चार्ज इनक्लोज्ड 10 टू द पावर -7 है फ्लक्स कितना हो जाएगा फ्लक्स इज क्यू इनक्लोज्ड अपॉन एप्सिलॉन नॉट और एप्सिलॉन नॉट की वैल्यू हमें पता है तो एप्सिलॉन नॉट की वैल्यू पुट करोगे एंड यू विल गेट द आंसर Q10 surface flux through closed surface depends only on charge enclosed and not on the external charge. तो external charge पे depend नहीं करेगा. So Q enclosed upon epsilon naught and the 10 to the power -7. So 0.11 Newton meters per coulomb. So it depends only on the charge enclosed inside the Gaussian surface. सेम क्वेश्चन जैसे हमने पहले शीट का किया था, अब हमें दिया है कि एक हेमिस्फीयर है, इसके सेंटर में यहाँ चार्ज पड़ा है। नाउ इट्स एन ओपन सरफेस, तो पहले हम इसे क्लोज्ड बना लेंगे। तो इसको ऐसे क्लोज कर दिया। नाउ इसे फ्लक्स थ्रू कंप्लीट स्फीयर इज इट्स क्यूब एप्सिलॉन नॉट हाफ। हेमिस्फीयर में से कितना हो जाएगा? इसका हाफ। क्यूब एप्सिलॉन नॉट। A spherical volume contains uniformly distributed charge. Find electric field inside the volume at a distance of 40 centimeter from the center. जैसे मैं चार्ज डिस्ट्रीब्यूशन ले लेता हूँ, इसमें यूनिफॉर्मली डिस्ट्रीब्यूटेड चार्ज है। We have to find electric field inside the volume at a distance of 40 centimeter. मतलब इसके अंदर एक और पॉइंट लिया, which is 40 centimeter from the center. हमने बताना है यहाँ पे इलेक्ट्रिक फील्ड कितना होगा इंटरनल पॉइंट पे। ये हमारा गॉसियन सरफेस हो गया। Gauss law is integration of E dot ds is q epsilon naught upon, so q enclosed upon epsilon naught. Enclosed charge कितना? Charge density into volume of Gaussian surface. Because charge density is unit volume पे कितना charge है। अगर unit volume पे charge है rho, तो charge inside the Gaussian surface is rho into the volume of Gaussian surface. तो हमने वो calculate कर लिया। Then area of Gaussian surface is so EDA is equals to q by epsilon naught. 4 pi cancel. E comes out to be rho r upon 3 epsilon naught. Rho given है हमें क्वेश्चन में, rho given है, rho is 2 into 10 to the power minus 4. R is 40 centimeters, so 0.4 meter. Epsilon naught is, so इसको solve कर लोगे तो you will get the answer. The electric field inside a charge distribution. Next is radius of gold nucleus is 79 and it's given mass atomic number is 79, radius is 7 Fermi. Assuming positive charge is uniformly distributed throughout the nuclear volume. Find strength of electric field at the surface of nucleus. Middle point of the radius. Assuming gold as a conductor, you can assume positive charge to be uniformly distributed, does not come on the outer surface. हमने assume करना है कि charge uniformly distributed है. Charge हमें पता है total charge. 79 coulombs. सरफेस पे इलेक्ट्रिक फील्ड निकालना है एट सरफेस। से अगर हम ऐसे लेते हैं और एक इंटरनल पॉइंट पे निकालना, एक निकालना है आर्बिट्ररी। सरफेस पे निकालोगे तो E is equals to, you can assume whole charge to be concentrated at the center also. At a distance R by 2 निकालोगे, हमने फॉर्मूला ड्राइव किया था। हमें Q पता है, इस केस में लेना है R is equals to R by 2। R को R by 2 पुट करोगे तो this becomes so you get 1 by 4 pi epsilon naught Q by 2 R square, और यहाँ पे 1 by 4 pi epsilon naught Q by R square। Q भी पता है, R भी पता है। R हमें given है 7 for me, Q is 79. So if you substitute the values, you will get the answer. So ये क्वेश्चन करके देखना, then we will do the remaining part.